All right, it is Advent of Code, day 5. Yeah, here we go. Okay, nums. Oh, okay, so this is some kind of graph problem, probably. Seed to soil map. Okay, so the fertilizer map, listing which seeds. Oops. Let's turn that off. Okay. Entire ranges of numbers that can be converted. Ah, I see. Okay, but these numbers are large, so we're gonna have to store them as like tuples. Okay, so I think what we do. Oh, this is gonna be annoying. We're gonna have to like keep segments, and then they're gonna split. So I guess you just keep mapping all the way through is probably what happens. So, or do the initial seeds only have? Oh, these are not ranges, right? So you only have a few numbers. First line is destination. Oh, well, yeah, this is that. These source numbers that aren't mapped correspond to the same destination number. What does that mean? Oh, I see. Okay. Let's see. So, I guess seeds s dot pop 0. Then let's do. Okay, yeah, and then these are the ranges. So I think what we'll just do, like, I think I'll just convert each of these other lines to, I think, so name, cut off the last 4, 5, and then, okay, seed, oh, whoops. Oh, oops. There we go. Okay, cool. That looks good. They're all just in order, right? Yes, I can verify that. So that is not necessary anymore. Don't need the name. So we're just going to, and then the cur is just going to be, I think, seeds. Cool. And then I think for each of these, we just like check the map. If for mi and m, so we need to find it. Okay, I think we just do if. So mi is expressed as start stop 2, and if start stop, then otherwise it's unchanged. So I think that's just it. So we deal the mapping this way. The closest location. Oh, the location's at the end. Okay. Find the lowest location number that corresponds to any of the initial seeds. I think cur and cur. No, 4 stops. What does M look like? M is in maps. Oh, whoops. R and X. Oh, we still need to do count type. Oh my god. Nope. Okay, what did I misread? Then it goes to humidity location. Convert it through each other category. Let's just do a simple sanity check, which is seeds. Let's make sure I still have 20 numbers. Yeah, I still have 20 numbers. Are they inclusive? That wouldn't. Oh, destination range. Oh, I completely misunderstood. Okay. If start let's do with I less than or equal to. Okay, so 50 and 51. Okay, so less than. So this is start dest size, start plus size, and if this is the case, then it becomes dest plus I minus start, I believe. I think that's right. No. Oh no, this is not great. Okay, let me actually read. Oh, you're kidding. It's destination then source then. Okay, well I'm gonna be locked out for a minute anyways, so I might as well try the sample input. Sample input I get 35. Yep, okay, so I think this is correct now. So I'm just gonna keep spamming this. Oh no. 24 seconds is already full. It's not already full, but I'm gonna get like something near the end. If I get it. I'm copying the right thing, right? Yeah. Oh, that was bad. 2 misreads. A destination source is pretty sad. Oh, man. 3, 2, 1. Rank 65. Okay. Yep. Figured. Okay, this is going to be annoying. I think no one had solved it anyways. Because now we need to deal with entire segments. 2 ranges of seed numbers. Okay, so now what we do. Okay, so translate segment is going to be, so we're gonna have an initial segment, and we're going to have a, okay, initial segment, and then we'll have a dest start size. So this corresponds to the map. And basically the segment can overlap in like some number of ways. So seg will be a tuple of like start, stop, inclusive. And the way this works, so stop will be start size minus 1. So this is now inclusive on the range side. Okay, so either it can be completely contained, it can be like overlapping left, overlapping on the right, or it can completely contain it, or it can just not be in there at all. Wait, I'm being a little silly, right? I think that it's just overlap start is just going to be the max of our segment start. I'll do seg start, seg stop, our seg start, and our this thing start. This is where the overlap starts, right? And this may be out of range. Overlap stop is min of seg stop and stop. And I think these should both be inclusive. So if overlap start is less than, or is greater than overlap stop, then no overlap. And in this case, let me think about the stop case. Yeah, I think this max min is right. God, I haven't thought about segments in a while. Okay, if this is the case, there's no overlap, and we do nothing. Okay, well, sure. In this case, we just return the entire segment. So I think what this is going to return, and this is going to return, it's going to return like translated segment. You can at most have one segment translated when you do this step. So this could be, it'll be a translated segment, which could be none, maybe none. And then it will be like remaining segments, maybe none. if the entire segment gets translated. Yeah, I think that's good. The fact that this handles that is nice. Okay, so in the case where there's no overlap, then the translated segment is nothing. And the remaining segment is just exactly what it was before, seg start, seg stop. In the case where the overlap is completely seg start, normally these wouldn't be a special case, but the fact that I'm like representing these with none is why I need to do this. So in this case, everything gets translated. So at this point, we can just translate overlap start now. So result start is going to be overlap start plus dest minus start. Yep. And then result stop is overlap stop plus dest minus start. And in this case, this is going to be result start, result stop, none. What's annoying is that actually if our segment is completely, oh wait, no. Yeah, we can't ever split this, right? No, we can translate like some part of the middle. If we translate some part of the middle, then the overlap, oh boy. This needs to be remaining segs. So this could be empty list. Ugh. Okay, so seg 4, this is getting really ugly. Just goes from seg start to overlap start minus 1. If, I'll do this. If overlap start is greater than seg start. So if we have a segment before the overlap, then we have something before. If overlap stop is, if the overlap stops before the segment stops, seg after, then we have a seg after, and that's seg stop plus 1, the overlap stop plus 1. Whoa. Hang on. No, the overlap stops here, and it goes all the way to seg stop. Okay. And then what we need to do is, these segments don't overlap, right? Yeah, they must not. Seg after empty. And now at this point, leftover segs will be seg before, seg after, and the translated seg. So at this point, we just return result start result. I think we don't actually need this case anymore. I think we just return this. I'm going to get rid of it because now we have the none. I don't like that. And this is just leftover seg. Okay, I think this works. So now what we do is we create our seed segments. I worry that our segments are going to explode exponentially. They can't do that. That's not true. Each line can at most, okay, I'll worry about this later. I should just write it. I'm already fully committed here. So seed segments now. So what we'll do, seed start, seed length. Let's make them inclusive now. Okay, so that's 14 numbers. That's start, what's this, minus 1. Assign the seed segments. And now for everything in the map, what we're gonna do, so we have some like per segments. And now what we need to do is we have, oh boy, new segments. I don't actually know how I'm gonna do this. Okay, I'll think about this later. For per segment in per segments, then what we try and do is for every translation thing here, we're gonna try and translate translated. So basically, the reason these are separate is that once they're translated, we can't translate them again. But everything that's remaining, we still need to check the other segments. And then the remaining segments, this is going to be the result of tseg. And our cur segment is, this is silly. And then def start size. Okay. So now we have that, and whatever's remaining needs to go into a. Oh, maybe what we try and do is we flip the order of these loops. And now we do new segments. Okay, well, we needed a new segments. And then anything translated gets thrown into new segments. Anything remaining should sort of stay new cur segments. My naming is terrible. New cur segments dot extend remaining. And then, so at this point, we have translated every segment according to this rule. And cur segments equals new cur segments. And then we go on to another rule. We try and translate everything according to that rule. At the end of this, whatever is left in cur segments is untranslated and should stay as is. So new segments dot extend cur segments. Cur segments equals new segments. Okay, lowest location number that corresponds to any of the initial seed numbers. Yeah, lowest location number. Okay, so I just want the min of the remaining segments now. What do seeds look like? Oh, seeds. Okay, and then how many segments do I have? Oh, that's a problem. I have a problem. If this is none, wait, yeah, for M and maps. Whoa, wait, what? Oh, I never add anything. Shoot. T-seek must be iterable, not int. Okay. I actually thought that would work. I'm kind of surprised it did not. What? Oh, that's why it didn't work. There's cur segments. Whoa, this is messed up. That is because we're appending a new segment. That is always a segment. This is a list. Here, it is not a list. Easy fix. Okay, cool. And then cur segments 0. This should just be print min of CS0 for CS and cur segments. That is this one, right? Rank 21. Okay, that was a good improvement. Oh man, that segment stuff was brutal. And part 1 was also not the greatest. Okay. Oh man. Wow. Yeah, just thinking about the 8 minutes is kind of crazy. I mean, I guess if I had like some segment code prepared, then maybe this would have been a lot easier. I actually, when I was parsing it, I thought that what part 1 would be was what part 2 ended up actually being. I sort of saw this sort of translation process and the fact that they were translating ranges, and I was like, oh no, they're going to have us do segments. Like we're going to have a bunch of seeds as input, and we're going to like translate everything and do this breaking up segments apart. Yeah, I was wrong, and part 1 was easier. I definitely struggled a bit on part 1. Let's take a look at what was my time on part 1? I got 65, I think. Yeah, 650. So I was locked out for like 50 seconds or something. So I guess that by itself was, it probably wasn't a whole 50, it's probably like 40 seconds. But that was 20 places-ish, 25 places. Yeah, that's pretty sad. That was purely a result of the fact that I did not realize it was destination then source. I thought it was source and then destination. That was a little disappointing. The first bug I had, I'm trying to remember what it was. Oh, the first bug was misunderstanding this. what I thought it was is that the first one was the source start. The second one was the source stop, and this was what you map everything to. In hindsight, you definitely like would not map everything to the same value, because like if you were working with segments, it wouldn't make sense. Everything would just collapse into like a few values. So I think my interpretation was very clearly not correct if I stopped to think about it much, but I did not stop to think about it much, so that's sad. But yeah, that's I'm still waiting for. I'm kind of curious how my global position will change, but I think it is going to be a little slow to fill up the first 100 for this part. Right now I'm up to number 2, which is pretty impressive. There are still how many points? Anyone coming in here can get like 65 points now. So who's like 65 points below me? That would be 570 or below. Oh, Jonathan Paulson already finished it. So I think my number 2 is cemented. As long as Jonathan Paulson finished. Yeah, he finished 11th. Okay, cool. Yeah, so that means I'm number 2 coming out of day 5. That's pretty cool. I'm quite happy with that. Even if I did like choke a little bit today. Cool. Yeah. So I'll talk a little bit about the problem now. Let's see. So the first part of the problem. So basically, like, I guess some amount of this is like parsing the input, but effectively you have these input seeds, and these are like maps that sort of tell you if you want to figure out like you have these seeds, and you need to go from seeds to soil. Like, I think they said soil kinds. These like types of things. And the way that this works is like the destination is 50, the source is 98, and there's 2 here. I guess that doesn't map any of these. This one will though. So destination is 52 and the source is 50, and there's 48 is like the number of things. So what that means effectively is that segment, so seeds 50 through 50 plus 48 minus 1 is going to be 97. Seeds 50 through 97 map to soils 52 through 99 is basically what this is saying. And I think like some amount of this problem was just realizing what it actually wanted you to do here. Like I said, I had some intuition for what to do, but it was like a little wrong. And I should have read a little more carefully today. But yeah, and the idea is that like if you have, I don't know, seed 60, right? This like maps to soil 62. And if you have seed like 43, it doesn't get mapped by either of these 2 rules, then it should just stay as soil 43. And the idea is you take the seeds, you feed them through all these maps, like you do this translation process, and at the very end you get like locations. And it's just asked like, what is the min location? And yeah, I think for the most part, you kind of just do this. Like there's a bit of math, but as you're going through, you just like keep some set of translated seeds and some set of untranslated seeds, or I say seeds. Really, it's like whatever the previous thing was. So you go map at a time. So initially it's seeds, and you try and translate each seed. And if you can translate it, then you do. And like this is just math. You do like seed minus source plus dest, and that's it. This is like assuming seed is between source and source plus size. Incidentally, I'll note that it's not often Advent of Code actually does things that are exclusive. I feel like Advent of Code often describes segments and stuff as inclusive on both sides, which can be easier to say, to like not have bugs, although it often makes your code less elegant because you need some like +1s in places. But because here they said this is like a number of things, it is actually exclusive on this side, and I think that's another thing to remember. But yeah, you basically do this check and then translate to this. And so every time you see a seed, you try and translate it, or you go rule by rule. I call these rules. You go each one at a time, and you try and translate it. If you can translate it, you do. You add it to some new list. And if you can't translate it, then you keep it in the old list. In the very end, everything left in the old list is like the things that have this rule apply, and you just add them to the new list, and you repeat with the next thing. And you just go one by one. part 2 basically now says, so the rules are all the same. You're still translating ranges like this, except now your inputs are not 4 numbers. They are ranges of numbers. So they're 79 to 79 plus 14 minus 1. Math is hard. What is this? That's going to be 92. Am I right? Yes. So this translates, so you have seeds 79 to 92. These are inclusive. And you also have seeds 55 to 67. And now you need to apply like the entire rule. So 55 to 67, this entire thing like fits within this range. So they all translate in the same way. So this would translate very easily to 57 to 69. 79 to 92. This also translates very easily. They didn't have a very great first example here. Or maybe they changed it. Well, anyways, this also translates fairly exactly. But what's important to realize here is that these are like segments, and these are also segments. And really what this question boils down to is like, what is the overlap? The overlap needs to be translated according to this rule, but whatever portion doesn't overlap needs to like not be translated, and you need to save it somewhere. So that's what I'm doing here in this function. And it's like pretty messy overlap code. But basically first I figure out where the overlap is. The overlap of any two segments, if they're sorted, so they have like A, B, and C, D, and A less than B, C less than D. Basically, the overlap, if these are both inclusive, is just going to be max of AC and min of BD. And if this is like an invalid segment, as in this is larger than this, then there's just no overlap. This is just a thing that you can realize and you can think about it. I think the more you thought about segments, the more obvious it is, and the more comfortable dealing with segments is. I guess once upon a time, I have thought about segments a lot for like leak code style problems. But anyways, that gives you the overlap. And then I basically do some cases to figure out where the non-overlap is. So this is a case where the overlap is the entire segment, the whole thing gets translated. This is the case where the overlap is invalid and nothing gets translated because there was no overlap. Otherwise, this just computes what the new segment of the overlap translates to. And then this figures out if there was, like, if the segment was something like, so I use segment to refer to the like input thing. So in this case, seeds. So if the segment here was like 55 to 78, and the translate was 60 to 70, then we have some like leftover on the left of 55 to 59. So this just computes leftover on the left. That's what seg before is. And then there's also like leftover on the right. And in this case, that's going to be 71 to 78. And these should stay untranslated. And there are cases where your leftover on the left is, like, you don't have leftover on the left and you do on the right. You could also have leftover on the left, but nothing on the right. And you could also have like nothing on either side. So doing it this way just like handles that. And then we're left with leftover segments. And then this part basically just goes through and does the translation. Once again, the reason we have to do it like this is like a little annoying, but normally, like as before, if we had a number and the number didn't map, we could kind of just leave it there. There was no such thing as like a partial mapping, but now it's possible for some of the segments to be translated and some of it not to be. And it's important to like separate these two parts. So the translated segment gets added to this like new segments list, whereas what's left gets added into this new cur segments to try again on another segment in the next iteration of this loop. Or sorry, try again on another range. I should really call I should call this thing the range and this thing the segment. My naming here was very inconsistent, but it made sense to me while I was coding, and I guess that's all that really matters. Yeah, I don't actually know I did a very good job explaining that, but that was the gist of today. I think by now the leaderboard should have probably filled. Let's take a look. Cool, nice. And I don't think my global will have moved, but okay, cool. Did not. Exciting to be number 2. Only 70-ish points away from Xiaowu. Did he? Wait, I feel like he was 700 before. Did he just miss today? Oh, he did. That's pretty sad. I wonder if he... I feel like there's no way that he would have done like poorly. Let me see if... we might be on a private leaderboard together, but... I guess I could check. Smarty... Oh, he did solve it. Wow, maybe he just missed leaderboard. That's crazy. I was thinking maybe he slept through it or something like I did on day 2, but I guess not. Huh. Well, anyways, that's day 5. I think I'll call it here. See you tomorrow.